Yep, hello everyone. We started a stream on both YouTube and peertube. At least I hope so. It was a goal for today to set up a restreaming. It was asked a few times and finally I hope it works. And today we will explore how to manage Guix deployments, and as an example we will set up NGINX server, which allows to restream using RTMP protocol to both platforms. The main tool for today is Guix deploy, but before using it we need to get a working Guix system, and it will be a VPS, and more specific, it will be a VPS converted from Ubuntu to Guix System. I made a chat available on my screen, so people who will come later will see it on recording, and if people watching the stream later on peertube, they will also see what was in the chat. So let's start from the simple step. We will convert Ubuntu to Guix System. For that we need a VPS with Ubuntu and SSH access to it. I already have it, and I already did a few commands. To be specific, it's apt-update and apt-install Guix. Few days ago I realized that there is a Guix package in Ubuntu, Ubuntu 21.04, and it was quite easy to install it. I just typed those two commands and got Guix. It's a little outdated. Actually, it's very outdated. It's a previous stable release 1.2, and to update it I typed Guix pull, and it takes a lot of time, around half an hour or something like that, on the small VPS. So I did it before the stream. You can repeat the step by just typing Guix pull. So I have Ubuntu fresh, without any additional stuff, just Ubuntu and Guix installed and updated. Only two commands. And now Guix pull updates only Guix for a current user, and current user is root. So I need to source the profile created by Guix pull to make a newer version of Guix available for my user. And for that I need to type those two commands, which you can see here. And now I have very fresh version of Guix. I hope everything works fine. For some reason there's some problem with CSS in the chat. Let me do a small trick. Okay, it doesn't solve the issue, but I hope I will see what you type, and we'll just read it. Okay, we already have Guix on our Ubuntu, and now we need to get some information about our VPS. I know that the VPS provider I use currently doesn't provide DHCP. It creates an image which has IP address and routes and everything else related to network defined statically. So I just need to get this information, and I will type ifconfig and route -n to get this information. Okay. I need IP address, netmask, and I need a gateway. And gateway is default gateway will be on the line which contains zeros in destination. So let's save this information somewhere. For example, here. I hope everyone can see the stream, because I have a notification from YouTube that there's something wrong with the keyframe frequency, but I hope it doesn't affect you. Oh, and I need a gateway. Here we go. Also, I know that DNS for this cloud provider is here, and I will copy those values in those strings, and I will explain in a minute for what we are doing it. The same here, like that. And I will comment it out, or maybe even remove it. Good. Here we have a definition of our Guix system. It's very simple system which only contains most essential information about bootloader, partitions, and two services. Static networking, which will use address, mask, gateway, name, and name service that we set here, and OpenSSH service, which uses OpenSSH without X package, and which uses a key, SSH key, that resides in the same directory. It's a public part of key pair. So I will be able to access this instance, this host, using my SSH key after I transform Ubuntu to Guix System. If your cloud provider has DHCP server for VPS and you obtain IP address using DHCP, you can just uncomment this line and comment this stuff. Oops. And it should work. Not much here, very basic system. And now we need to copy this file to remote host. For this, I will open nix-shell and will use trump to navigate to remote host. IP address, I will use this one, and I need to go to root directory. And now I am in root directory of remote host. Here I will create few files, and first will be a copy of this file. I can just copy work drop in Guix base SCM. And now I have the file here, and also I need a key which called SSH key. It's just a key obtained with SSH add -l command, and here you can see my public key. I just copied it to the file and saved it to the directory in my project. Now I have a base system and SSH key on my remote host. Actually, I will switch to the terminal, and here you see those files appeared in the root home folder. Now I need to do a very simple command. I need to build my system. I will type Guix System build and pass a file to this command as an argument. It will take some time to download and build the system, but I expect it to be just a few minutes. Oops. While it builds, I will say a few words about Trump. Trump allows to operate on remote files using different protocols. For example, the SSH, sudo, probably FTP, and many other protocols that can be used with Trump. Actually, it's even possible to use Trump to interact with Docker containers, which may exist on a remote host. That means you can CD or do other stuff using SSH, and inside this SSH tunnel you can go inside Docker container. So it's quite powerful tool which allows to do everything related to communication with remote host inside Emacs. And here is a template of simple command which uses Trump to just navigate inside remote directory in nix-shell. You can do the same by using this path inside your other Emacs tools. For example, here I called find file command, and let's go to this Emacs instance, and here you can see in find file dialog it asked me for it provided me with completion for the remote host, and now I can pick a different directory on remote host, for example etc, and here probably system D directory, which the directory created by Ubuntu. And now I have dirt run on my local Emacs instance, but showing me a remote file system, which is quite cool feature in my opinion. You can use your environment, your local environment, with remote system. It seems that system already built and available here, and we can take a look what is inside. We see activate script, etc folder, profile with packages installed, and so on. And now we need to activate the system. But before activating it, we need to clean up some stuff that was produced by Ubuntu. And to do that, we will use few commands from init.sh script. Actually, I don't need a separate script for that. I just can copy those commands here, what we will do, we will move all folders from etc to old etc, just to make sure that we can restore it if we want. And now we doesn't have etc on remote host. And now we will copy a few files which are necessary for Guix to work, to continue system reconfiguration. I will create folder back and will copy those files. It's mostly the information about mounted file systems and about users and groups. And now I can type Guix System reconfigure and we'll type the name of the file. And now it failed. Okay. It failed because it can't access network. I don't know why it won't access the network, but we need one more file from etc which called resolve.conf. Probably it will be enough for Guix System to continue the work. Bam. Okay, probably there's some other files. Let's restore back our old etc completely. Let's remove etc, copy old etc to etc, and let's try to reconfigure. Now it will complain about conflicting files like SSL. Oh, it still complains about the network. Very strange. Okay, it works now. Okay, and now it complains about symlinks. Let's repeat the operation one more time. rm etc, and let's copy some files. Oops. And now reconfigure one more time. You can probably ask why we do so strange thing as converting Ubuntu into Guix System. Actually, we could install Guix System just from image that we can build with Guix System image subaction. But I already had an Ubuntu VPS and I decided to just convert it to Guix System, and I succeed with it. So today I show you what I did and how I did it. That is why we picked this way, but you can and probably it will be easier to just make cookav to image or some other image which is supported by your VPS provider or maybe real hardware provider, and just install the Guix system from this image. Here it complained about Shepherd, but it seems that it installed a bootloader, so we can reboot, and after reboot it should load the Guix system. Okay, let's hope that I didn't forget anything, and let's try get back to the host. There is no more comments in my cheat sheet, so I hope it should be fine. Okay, now it complains that the fingerprint of the host updated, which is quite obvious from the output of the command that we saw earlier. Somewhere here we saw that it generates new host keys, and that is why fingerprint doesn't match. We can just delete known hosts. It's much better to not to do it, but just update the line which is present here. But I have known host backed up, and that is why I will just delete it, not to spend time editing the file. And now let's try to log into it one more time. And now it we already on remote host, and it complains about less pipe, and it complains because there is a bash rc file which contains this line. I will just comment it, and now I can relogin back to the host, and there is no error message. It's a ls pipe command which was installed in Ubuntu, but not available in Guix system. And now I can type heard status, and I will see that Shepherd is available on this system, and there are a lot of services managed by Shepherd, which is good because it means that Shepherd was run during boot process, and probably it's our init process, and we have a Guix system. Now we have very basic Guix system without any fancy stuff, no additional packages or services, but it's already a Guix system, complete Guix system with Guix Diamond and other stuff. And now we can manage it with Guix deploy tool. What we will do, we will create one more file, which let's call system scm, and we'll copy the content of our base scm file. We have the values like IP address and all other stuff. Let's move this value to a separate variable called host. We will use it in one more place in just a few seconds. And let's open another file on the right pane. Let's open restream file, which contains the configuration of VPS, which is used for restreaming, and it's already deployed. I will just copy some fragments and explain them, not to type them one more time. Here, I define a list of one machine which has operating system equal to OS. Let's define those variable. Define OS, and the value of the OS will be the value returned by getOS function, which just returns operating system with IP netmask gateway name servers equal to the values provided to this function. And there's a configuration for how to access this host. It will be accessed by hostname or by IP address, which I put in host variable, and here we use this variable. We know that it will be AMD64 system, and host key is equal to some value. Actually, we can copy this value from known hosts. SSH known hosts. We'll just copy it and we'll place it here. Actually, we doesn't have to set this field. In this case, it will look for the fingerprint in known hosts file, but it's better to do it here because it's first recommended by developers of Guix deploy, and the second, you doesn't depend on the environment. That means that this file will contain all the necessary information on for the deployment and can be used on a different host with different environment, which can have a different known hosts file in SSH directory. So to prevent this situation when the file describing the deployment works on one machine and doesn't work on another, we set up host key explicitly here, and we log in as a root. Maybe not the best idea for some serious system, but for our use case where we manage a simple VPS for some simple needs and we're not restricted with security requirements, it's quite okay to use a root. And port 22 also isn't the best security option, but just fine for our use case. Now we have everything related to our deploy configuration here set in correct way. Now we can just update our definition of operating system. First of all, let's change host name. Here you can see that we log in as a root user at VM host. Let's change it to NGINX test server, for example. And what we will do, we will create a target in makefile for our project, which will be deploying our NGINX test server. And this target, makefile target, we will run this command. Nothing special about it. If you're not familiar with makefiles, you can just use this command. But I will be using makefile because I have a hotkey for invoking make inside the project, and I will invoke make with deploy NGINX server target. oh, how I called it, deploy NGINX test server. Okay, NGINX test server, and it will just run a Guix deploy command, which will try to deploy something to remote host. But before doing it, I need to add one more item to this definition, to the definition of our operating system. Here, when we defined machine SSH configuration, we had few more arguments which are explicit, and to find them, I will start a REPL using Ctrl+C, Ctrl+A hotkey. I will evaluate this namespace, and it will throw an error which says something about targets. Okay. Probably I need to add Guix source code to load pass, and now it still throws an error. Okay, let me restart the REPL. Add GNU Guix to load pass and try to evaluate namespace. It throws another error because I've not compiled something in my GNU Guix directory. Okay, let's use old target field here. Whoops. I accidentally ran a different command. It still complains about something. Subform was line 40. Okay. I will find the reason why it doesn't work later on my own. Let's do this this way. I will open machine model and we'll find a record that we are interested in. Actually, it's a definition of machine record, but we need machine SSH model, and here, somewhere here, we have machine SSH configuration, which has a lot of different fields, and we see that some fields has different values. For example, build locally, authorize, allow downgrades, and so on. There are port and user default values, so we didn't have to set them up, but for some reason they're here, and it's explicit and okay to have them. But there are also some fields that we didn't define, but which have default values. For example, build locally and authorize. What authorize field do? Build locally is obvious. We build the operating system that will be deployed on remote host on our local machine, and just copy items from our GNU store to remote store. So if we disable this flag, if we set it to false, the operating system will be built on remote host. Authorize allows to install the items from our local store built on our local machine on the remote store. It automatically adds our sign-in key, which signs builded artifacts to remote host. But after we finish reconfigure, this file which contains those keys will be overridden by service, by Guix System service, and it is a service which is a part of base services, and it's called Guix service, which contains the configuration of Guix daemon, and one of the fields of this configuration is authorized keys. And what we need to do, we need to change our list. Base services is just a list of services, and here, instead of using base services as they defined originally, we take this list and update one item in this list which matches the Guix service type. And here we say that we take original config, create a new config equal to the original, but with one updated field, which is authorized keys field, and the value of this field will be, oops, actually I misplaced, no, I didn't. Let's reformat it a little. Which appends to the list of authorized keys our key from our local system. So the remote Guix daemon will be aware of our sign-in key, the public part of it, and will accept the build artifacts, which is provided by Guix deploy command. And now we build a system which will be, I hope, successfully deployed with just a Guix deploy command to remote server. For now, it's probably not the most user-friendliest experience, but at least it works. We see that it's successfully deployed in NGINX server. And if we go back to our remote host, let's relog into it. Now we see the host name is changed. And that means that our configuration for the system is applied. That means that we deployed the whole operating system in one command. We have a definition of operating system. we have a definition of remote host and all necessary information about it. And now we can use this information to do deployments. Guix deploy command accepts a file, a scheme file which returns a list of machines to be deployed, and our list of machines contains only one machine for now. It builds operating system with all the predefined configuration and deploys it to remote host. That's it. I will go to the directory. Let's go to the project shell, and here I will just call Guix deploy Guix System S7. I will make the same steps that I did before using makefiles, but I did it manually in eShell for clarity, for people who may be not aware of what happened when I typed few keystrokes in Emacs, and it should be more explicit for understanding, and it repeats the process that was done before, but it doesn't rebuild too much, so it ends in a few seconds. And as we see, it's deployed successfully. And now let's do some additional configuration of our remote host. And here, for my example, we will let's create an NGINX configuration, which will be serving a static file. For that, we will need to add a service. We are already talking for 40 minutes. So I think 10 more minutes and I would like to finish. So let's make a pretty simple configuration, but I will explain how to do it yourself. I look for NGINX configuration inside Guix manual, and I need a data type which says NGINX configuration. I know that there is an NGINX service type, and to define NGINX service I need something like that. I will just copy the example from the documentation. It defines NGINX service type with NGINX configuration, which contains one server block. And here we have NGINX server configuration, which is a record defining a part of NGINX configuration related to one server. And for server name, we will be using the host or IP. We will take for the clarity, I won't be using those quotes, quasi-quotes and unquote syntax. I will just use a simple list. So the server name accepts a list of host names or IP addresses, and the root is defines the path to the directory which will contain files that we will be serving. It should be enough, I think, for simple NGINX configuration. And let's check that our remote host doesn't have NGINX. As you can see, it says service NGINX couldn't be found. We will try to make a deployment and it will complain about unbound variable because we not imported a model which contains a definition of NGINX service type, and here using use service models we imported it. It's actually just a shorthand for use models GNU services web. And here it's a shorthand for 3 use models. Exception. It failed to run Nginx server. Let's see. It is enabled, it is stopped, but it appeared, at least in our herd. Probably something wrong with Nginx configuration. What I did wrong with it? Let me see to my Nginx configuration. It looks almost the same. Server blocks. Okay, maybe it requires ports for listening. Let's rebuild our operating system and we'll deploy it. Actually, we doesn't have to deploy it. We can just build it locally and see what it contains before sending it to the remote host. But because we change only small part of the system, it's very cost effective in terms of bandwidth to deploy the system, because it deploys only parts which differs. That means here it will deploy probably new Nginx configuration and few scripts that activates new system. And here we see that it doesn't complain anymore about starting Nginx. And let's see what the status of the Nginx. And we see that it runs and the value is process ID of Nginx, and we can see NGINX. We see that the process ID here is equal to what Shepherd says, and here we see a configuration which is used for our Nginx, and it's generated from the definition that we used in our operating system here. The implementation of the stuff we can find in the namespace I mentioned earlier. Let me show you. GNU services web, and here already on the line where it is defined, it's line 668. Here you can see the way the Nginx configuration generated from the record provided to it as argument. And here you see nothing too interesting. This way server blocks appears in Nginx configuration. It just maps over server blocks with emit Nginx server config function, which is basically returns probably a string. Let's find the definition of this function. Here it defines some list, which is basically just a concatenation of different strings, which results in this configuration file. Okay, let's check that this NGINX works. Actually, it NGINX probably, but I called it differently because of the habit. It works, but it says 404 error, and it is because we doesn't have a directory which should contain our index.html file. Let's create this directory, and actually let's go to the directory and edit index.html file here. Hello from Guix host. And we updated, and we can see that there is hello from Guix host here. I will post a link and you can check it yourself. That it is really deployed on the remote server. Probably later, when you will be watching the recording, I will remove this server, but right now you can try it yourself. Okay, we did a very simple configuration, but it's very strange syntax to write NGINX configuration this way, and the question is why we have to do it. We don't have to do it. We can use extra config field, which is a little misleading, the name for the field, because it completely overrides the value or not. Let me see. It's extra content. Extra content field, which adds the content of this field to the end of configuration, but not to the very end, but to the end of HTTP section, which sometimes is not desirable. And here you see the solution for this. I just close HTTP section and starts new one, and doesn't close it because it will be closed by the system which generates NGINX configuration. It's quite hacky, but it works. But also I can provide a file, and here I can provide a file like object, local file. Let's call it nginx conf, and let's edit this file. What? For some reason it doesn't. Okay. Future history doesn't work here. A little strange, but okay. What we say here, instead of generating configuration using this a little strange notation and Lisp language, we can just specify a file like object, which is returned by local file function, and I just created an empty nginx config, and I can write something into it. Let's write almost the same content as it was before. But we'll remove some stuff that we don't like, for example. user NGINX. Let's remove, for example, this stuff and this stuff, and this stuff. We'll just clean up the config a little bit. And let's rebuild our system. It's very funny, but from the statistics, I see that people coming to the end of the stream. Actually, we almost finished and talked about probably all of most important things. But here I show a few metrics how to define and deploy NGINX configuration with Guix deploy, and we will conclude our stream, I think. Okay, it is deployed, and let's restart our NGINX server, and let's see which configuration it uses. And as we can see, it uses simplified version of our configurations that we defined. It works the same way right now, but you see, I didn't use any of this fancy scheme code to generate config. I just placed a plain text file with the content of the configuration for NGINX. But why someone can want to use this fancy scheme configuration for NGINX, I will explain in the next example. And this example will add a model to the NGINX. And we will add a model in the following way. We will define models field of NGINX configuration, which contains a list of models. And each element of this list is file-like object, and here we create a file-like object which will be translated to the string and will be placed in the configuration, but it will also install the package in the GNU store which contains NGINX model. And here I install NGINX RTMP model, from NGINX RTMP model package, and to check that such package exists, we can search for NGINX RTMP, and we see that there is such package, and we actually can not only search for it, but we can build this package, NGINX RTMP model. And we see it returns the path to the store. It doesn't build it because I already built it before the stream. We want to go to the folder with this model, and we can see that there's few directories, and one of them etc NGINX models subdirectory, which contains the actual binary, which can be included into NGINX by calling load model function and specifying this whole path manually, which is not very cool. We can just define a models section in our NGINX configuration record, which contains a list which contains this string, this call to file append function, which takes the package and the rest of the path. We saw that inside our package, which is in our store, we had to go to this directory to see this model, to this directory I mean, and that's this line will add a proper load model directive to our Nginx configuration. And actually, when we update our RTMP model package and version will change, the hash will change, the value of the path for load model directive in Nginx configuration will be updated automatically. So we won't change anything here, but someone will update RTMP model package, and the Nginx configuration will be updated automatically on next deployment. And let's see which configuration will be generated by our Guix. We need to add a package to use models, a model which contain a package Just checking that stream on peertube still works quite good. Our configuration deployed. We will restart our Nginx one more time and we'll see the content of the configuration file. And you see here a new directive appeared, load model, and the full path to the binary, to the Nginx RTMP model library. And that's actually pretty neat. This path is automatically generated, and we don't need to care about keeping it up to date because it's updated by our code automatically. Cool. We have our Nginx configuration, but more importantly, we have this directory in our system. And if we take a look at this directory, we see that it contains this model. So our deployment tool not only installed a configuration, but also installed a related model which was referenced by this configuration. And it's a cool property of such configuration that we can reference packages inside configurations, and those packages will be available in the store. And also we can share some values. As you saw here, we use IP for configuring our network, but we also use the same IP for configuring our Nginx. And this is two reasons why someone will want to use Scheme for configuring Nginx. There are few more reasons to do it, but probably you will find them in my other streams. And the last trick that I want to talk about today is how to provide credentials. For example, somewhere in my Nginx configuration I want to use some credentials. The very simple approach is to use env.rc file, which will be sourced by dir-env utility and set some environment variables, and later use this environment variables here in the code. You can set not only credentials but some things which can change between projects, but for example you share the code between few projects, and for example here I can have a host IP variable and I will be obtaining it with get-env function. So when I will call Guix deploy command with this environment variable set to the correct value, and it will be set to the correct value when I am in the directory of the project, this value will be will appear in place of this call, and it will be used inside this file in the places where this variable is mentioned, here and here. So it is a very simple way to set some credentials, some values that can be changed between deployment environment or between different projects. You set them per project using environment variables, and they will be used whenever they need it. Actually, you can learn a little more about such approach in 12-factor app, and in my previous stream about environment variables, one of the previous streams, per project dev environment it called, and here I talk about dir-env and its integration with Emacs and how to create per project environments. Cool. Let's go back to our notes. We talked about converting Ubuntu to Guix System, about Guix deploy utility, about configuring NGINX. What we didn't done today, we didn't done automatic restart of NGINX on deploy. I will provide you with idea how to do it. It's relatively simple. For that we need to call hard restart NGINX during activation. So at the end of system reconfiguration phase, activation script will call hard restart NGINX, and NGINX will be restarted. It's easy to do with Guix System services by extending activation service type with some J expression which calls this command, and it is an exercise for you. You can share your solutions with me using Mastodon or email, or you can ask for help if you can do it yourself, but try to do it. It's a good learning experience for using Guix System services. They're probably recording for the stream about Guix System services that you can watch to get more knowledge about this topic. And I think that's it for today. We explored quite cool, maybe not production ready, but already working pretty well Guix deploy tool. Probably when more people will be using it, it will get much more support for different platforms, cloud providers, or use cases. It's already supports, for example, DigitalOcean, so you can not only configure some instances, but it can create new instances using your definition of machines. Quite interesting feature. The only downside of it doesn't remove previous instances after new deployment, but still quite cool. And probably with more time we will get a more powerful tool for managing deployments with Git. And that's it for today. Thank you for your attention. See you next time. Bye.